So, hello everyone. I couldn't come to Dublin tonight, but a little piece of Dublin came to me. So I will drink this wonderful beer. Oh, let's see whether it works. And I will talk a little bit about the time. So how do we pour it into the glass?
You need to, you need to tilt it a little bit. Yeah, very good. Very good pouring technique.
Oh, and there is some bowl?
Yeah, yeah.
Okay. The glass, this is a glass for standard one Czech beer. So there is enough space for.
But the shape matters. But yeah, I'll give you that one. I'll cut you some slack. It's all right. Cheers.
Cheers. Oh, okay. So a day has only 24 plus or minus 1 hour, and I have about half an hour to speak about that. So there are 3 topics that I'm going to speak about tonight. How to check the current time. You shouldn't check the current time too often, and you should check what your government does. My name is Miroslav Šedivý. I was born in Bratislava in Czechoslovakia, which is the time zone of Europe, Bratislava. Studied at the National Institute for Applied Sciences in Lyon in France, which is the Europe-Paris time zone. And now I'm working at the Luther GmbH in Karlsruhe in Germany, which is the Euro-Berlin time zone. Karlsruhe is next to the French border, so this is the region of the best German wine and the best French beer. So here it is. So you see that actually I live my whole somewhere in more or less in Central Europe. So should I speak about time zones if I have never moved to another one? Well, let's see whether we can find some interesting information about time zone and learn something. I'm going to give some live coding tonight. So if you want to try the code with me, imagine that the time is set to Wednesday, 8th of July, 2020, 19:03 of IST here in Dublin, which is 20 hours and 3 minutes of Central European time, summertime here in Karlsruhe in Germany. What does IST actually mean? We are going to see it a little bit later. So my following slides are based on this time, so I'm not going to do any live coding. In Python, if you want to get the current time, you just import the standard datetime library, and you can ask, give me datetime now, and it gives you a datetime object with a year, month, a day, hour, minute, second, and microseconds that is based on the time zone of your computer. So in your case, it would be now 19:03, so 7:03 p.m. In Dublin. If I start the same code on my computer, here in my computer is set to the German time zone, I will get a different timestamp, which is 1 hour ahead of Dublin. So actually, at the same time, my and your computer will generate 2 timestamps that are comparable, but that are 1 hour of difference. And this is not what we actually want. Because if there is a server set to UTC time zone, it will return another datetime object that is set to 18:03, so another timestamp in the history, although it is actually the same time everywhere, but not the same datetime object. So if we want to work with the same time, you should use datetime UTC now, which returns the current time in UTC, but on every computer. And then we can compare our datetime objects, and they will be identical. And it doesn't mind which time zone you're on my computer have. But on the other hand, there is no information that it is in UTC. So we know only implicitly that we have a datetime object that that is in UTC, but we can only live in the UTC world. So there is a standard library module datetime time zone that will allow you to use the UTC time zone and return the correct object with the information, with the tz info that we are in UTC. This object is now bulletproof, and it will always point to the right moment in the history and on any computer, and you can store it, you can read it, and it will always point to the same time. But it points to UTC, and if you want to know what is the current time in Ireland, now. So you are now 1 hour ahead of UTC. So you can start now with this time zone that is set to time delta to 1 hour ahead of UTC. And you will get the current time, so 1903, and with the information that you are 1 hour ahead of UTC. But this is something that works now, but in winter, you would have to know that you are not ahead of UTC, but you are at the same time zone. So this is not something that that works at any time during the year. But fortunately, there are some libraries that will allow you to work with the current time in Dublin. For example, the well-known third-party library pytz. And then you will only say, I want the current time. So now in the time zone of Europe Dublin, and you will get the right information with 1903 and with the information that we are in Europe Dublin and 1 hour ahead of UTC. But the problem is...
If I may have a question already.
Yeah,
for you.
Of course, yeah.
I don't know, you didn't set a policy about questions. If we had to wait till the end, you know, to
No.
the success. But if I put the time zone here, Europe, Dublin, I never said, or the output never really mentions if we are in daylight saving time or if we are not.
If you give the time zone to the time zone object of your Berlin to daytime now, it will know whether you are in a daylight saving time or not. Because
and it's not in the output.
In the output, you see it because there is IST plus 1 STD. So this is the standard Irish time. If you run this in winter, you will get different information at the end.
Excellent, thank you.
There will be, if you run this in winter, I don't have the example, but there will be the STD info, Europe Dublin, and there will be something else. So you will see that you are not +1, but you are +0. So the information is there. And this is the time zone that, this is the data object that contains all information that you need. Okay, so now let's get back. We saw at the beginning this daytime now. I want to tell you, avoid daytime now. Because if you get this daytime now, you see that there is 2020, 8, 19, 0. It is the current time here in Dublin. The information is not in the object, and you would have to add the time zone information to this object, but only afterwards. Why don't you do it immediately? If you add this time zone object afterwards, and you replace this desert info that is originally none, and you replace it with Europe Dublin, what you get is daytime object that has the correct year, month, day, hour, minute, second, microsecond. But what you see in this desert info Europe Dublin, you see this LMT -1 day 2335 STD. So this is wrong. Never do it like this. With pytz object, you have to use the localize, because pytz is not standard. Doesn't use the standard functionality of daytime, and you cannot just add a pytz object to the daytime object. You have to put the daytime object to the pytz object, and this, if you do is like this, pytz time zone in Berlin localize, and the naive time zone naive daytime object get the right information. You see at the end of this line, you have now Europe Dublin IST +1, which is the right time zone, the right UTC offset that is valid now. If I take these two objects and I calculate the difference, I will get 5,100 seconds of difference, which is exactly the difference between +1 hour and -25 minutes. pytz is not the best way to edit the time zone information. It is recommended to use daydutil import tz. Now you can actually, what you can do is to replace the tz info information, and now it will be correct. What you see now in this daytime object is tz file object. There is user share zone info Euro Berlin. It means that it touches or reads the time zone information from my computer, from my host. This is recommended in Python up to Python 3.9, because in Python 3.9 there is 6.5, And that's the support for IANA time zone database in the standard library that uses the system visit info. And there you just import any third-party libraries. This is directly in the standard lib. You import zone info, and then you can work with the zone info information. You put this Dublin, and you get the correct information. This is in Python 3.9. There are backports for 3.8, I think also for 3.7. So just check for the zone info. And this uses what you have on your computer. So we have seen there are some libraries like pytz, util, zone info. There are plenty of other libraries that will allow you to work with datetimes like arrow and pendulum. Use whatever works for you. But code, but still there is this information. Is it daylight saving time here? Are we 1 or 2 hours ahead of UTC? This information has to come somehow to your computer, and this is visit info we are going to look at. I have 2 more tips for you about time. We see already now how to check for the current time. Let's say that we want to generate 2 strings, one with the current date and another string with the current weekday, and we write these 2 lines of code and then start them. And they may be wrong. They will be wrong in the moment when you're not in front of your computer, probably. Because if you start these 2 lines of code 1 nanosecond or 1 microsecond before midnight, the first line will execute the second line will execute on Thursday. So you will get 2 datetime strings that are not connected to each other because you checked your current time twice on 2 different days. It's not very probable that something that happens, but if that happens, you are not going to debug that. So it's much better to look at your watch only once, save the current time, and then work with it. If you have some method that works with the current time, that it was about some recurrent events and calculates formats some string, always at the beginning just ask for the current time and then work with it. It's much easier to debug if you run into such problems. So check for the current time only once. But there is an exception. There is an exception when you want to check for the current time several times, and it's if you want, in your runtime, if you want to measure some expensive operation, something like a download of a file, you want to check the current time at the beginning and run this expensive operation, then make the end. Then you calculate the difference between these 2 datetime objects, and you ask for total seconds, and you will get the number of seconds as a float. A few days ago, I learned the possibility to divide 2 time delta objects. So if you have 1 time delta object, like the difference between time delta object, you can divide them and you will get a float. So for example, if you divide end minus start, divide it with time delta in days, you will get the float part of the day, how long time it took. These datetime objects are great if you work really with datetimes, but in this case, we just need seconds. So we need number of seconds. So it's much easier to take the standard time library module and then ask for the current time. You get a float. This is the number of seconds since epoch. And at the end, again, for the current time, and you get 2 floats and you calculate the difference, and that's okay. But that can also break in the case if during this expensive operation, your system sets the clock, the MTP runs, and fixes or corrects the clock of your computer that runs wrong. So in that case, it can happen that end will happen before start if your computer is off a few seconds and it set the correct time during expensive operation. Fortunately, there is something like time monotonic, and this is a function that returns a float in seconds since some not important time in the history, because there is no difference if you have the number of seconds since 1970 or since the start of the process. And this is guaranteed to be always monotonically increasing. So end will be always after start, even if during the expensive operation, your the clock will be set. And there are even monotonic in nanoseconds, so you can work even more exactly. So that was Python. Now let's get to time. How do you measure time? Earlier, it was easy just to check for the sun when it was at the highest position at noon, then wait until the next noon, and then check the current time, and then divide this by 24. But it was wrong, because the sun doesn't, or the Earth doesn't turn regularly around the sun. And there is something like a time equation, and it is something that probably have seen on some solar clock. It looks like an 8. Look like an 8, and this 8 defines the position, the relative position of our sun during the solar noon, or during the noon, which means that the position of sun and Earth at noon oscillates by up to 15 minutes during a year. So there is not all, we don't always have 24 hours between two noons. The people, of course, found it out. They calculated it more exactly, and then we have something like local time, because you were in a city, and then to get to the other city, it took so long that it didn't matter that in some other city the noon was a few minutes later or earlier than in your city. But with the railroad, we needed, of course, something like exact time. Because on single tracks between two cities, you didn't want to send two trains at the same time, because they didn't have the correct, the same time. So they started to put, or to organize some central times of kingdoms or of countries around some observatories in the capitals. So there is this Greenwich, and other cities or other countries around the world, they start to adapt to Greenwich sooner or later. So easy, you have London with Greenwich, and then you have 12, so around about 25 time zones around the world. This is how it would look like at the end of the 19th century, or beginning of the 20th. But then, unfortunately, or fortunately for my talk, there was the politics that came onto the stage. And there were so many changes around the world where some countries decided, oh no, we are going to do that. You see, for example, this is Europe with Greenwich at 0 degrees. The next hour is centered around Prague with 15 degrees. And the border between them is at 7.5 degrees, which is almost exactly not far away from here. I actually, where I live is next to the easternmost point of France, this little triangle in Germany. So we should be actually at the border between the Central European time and Western European time, or Greenwich time. But it is not like that. You know that Benelux, France, and Spain, they use the same time as we use in Central Europe, in Germany or in Czechoslovakia. This was in 1940 when Hitler invaded Benelux and France. He moved everything to the German time. And Franco in Spain was so excited that he said, okay, we are also going to move to the German time. It was 8 years ago, but it didn't change since then. Of course, there were daylight saving time and so on, but it didn't change. And you see that Ireland actually, not Dublin, but most of Ireland belongs even further than Greenwich. Yeah, because you are even further than the 7.5 degrees of the Western longitude. So this is how it should look like. No, it doesn't look like that, you know. Why do we have so many time zones? In PyTZ or in the TZ info, there are 440 time zones defined. These are not these 25 that I was speaking about, because you know there are some time zones that are half an hour or quarter hour ahead or offset. This is something that is defined based on all the countries that existed since 1970 and all the regions that sometimes since 1970 had a different time at any moment between 1970 and today, comparing to the some other place of their country. The same colors are the same time. So now in summer, you see that our blue Central European time zone is offset to the Eastern Africa because we are 1 hour ahead because of the daylight saving time. And also Ireland, yellow, has the same time as Central Africa, Cameroon. So this is also because of the daylight saving time. There are some time zones in Australia, in Antarctica, all around the world. Where does this information come from? Go to IANA.org, because there is no central committee that decides about the time zones. There is this IANA assigned to number association, which is of time zones around the world, and put them into a database. So if you go to this website, there are two things. One is a mailing list, mailing list where everyone or the people write about the changes in time zones. And there is this file, visit data. The current one is 2020A, so it is always year and then letter ABCD within the year. And this is half a megabyte or less than half a megabyte file that contains a few files, a few programs. I see Oak, I see Shell, some README information, but the most important thing are files called Africa, Antarctica, Asia, North America, Europe, and so on. And you see, for example, Europe, 170 kilobytes. This is a file that contains two things. It contains the information, the computer information that will be translated into database, the TZ database on your computer of your system. There are some other programming languages and database systems that use their own copy of this information. So PostgreSQL or Python. There are some Linux distributions that use their own distribution or their own version of TZ data. There are others that use what is stored in user share in this database. And so there are this program or programmatically readable information, and there are the comments. And the comments, this is like a book. I absolutely recommend you to have a look at it. We'll read a few lines of it later, but it's the information that comes from this mailing list, and that comments why some information in this database, where it comes from, why is it like there, and the whole discussion is there. If there is one picture that you want to take from today's presentation, this is it. You have to turn your heads to the left, I mean my left, your left. You see these numbers 0, minus 15, plus 15 on the left. The 0 is Europe, like Greenwich. Then to the top it is East, so Asia and Australia. Around 0, it's Europe and Africa, and on the bottom is the offset to the direction of America, and the years end of 19th century up to 2040. So what you see here are all the 440 time zones, how they changed during the times. At the beginning, you see the lines are random. This is the local mean time. So what you see sometimes LMT means local mean time. Local, of course. Mean, this is calculated from this solar time equation. So this 8 that I described you. So mean, it means that we are going to calculate the mean of all the moons during the year. So we have always for. And you see that these lines, they crystallize to more or less 25 lines sooner or later. And then what you see are small ticks. These are daylight saving time. Then sometimes you see longer jumps. Maybe there are some territories overseas that were earlier with their original country, and then they changed to their own time zone. And probably you can see a little bit later some jumps through the whole Hague. And that's the There are some islands in the Pacific that skipped one day. They moved just around the 180 degrees from one side to the other side. We are at 2020, and you see that these all lines, they continue up to 2038. This is actually this Y2K 38 problem, because now the current information is we are going to, if we have daylight saving time, end of March, end of October, we are going to use it until always, like until 2038. This means that if suddenly your country decides to stop using daylight saving time, you will have to get a new version, because with this version you will keep changing daylight saving time. If you think I have a perfectly tested program, I have it somewhere in virtual and in Docker, and I'm not going to touch it for the next 20 years, you will have to touch it, because if the time zone information changes, your program will have a problem. Let's have a concrete look now here in Dublin. The blue line is Berlin, and the red line is Dublin. So you see that you started 25 minutes behind GM, like UTC. And then 1916, I think, there was the first daylight saving time. So jump 1 hour ahead, and then going back to the standard time. Dublin.
But to be fair, it was a different country then. Eh?
Yeah. But yeah, exactly. Yeah. So before, of course, it was UK, and then the independence, and then they got the time of London, and then you use daylight saving time except for the World War II and around the 70s, the whole time. In Germany, it was a little bit different. Like Berlin is not far away from its 15th degree, so Berlin was not that far from 1 hour ahead of UTC. World War I, there was some daylight saving time. World War II, and in World War II, at the end of the World War II, you see 2 jumps up to 3. This is Berlin, and Berlin at the end of World War II was a Soviet zone. So for a short time period, they used the Moscow time. So it means that you can use this information about daylight saving times many years ago only for the city. Germany looks now a little bit different than it looked before. And for example, Karlsruhe, where I live, it didn't use the Moscow time. So for Germany, there is this time zone Euro-Berlin that before 1970 worked for maybe for the whole country, but it is not guaranteed, but it worked for Berlin. Only since 1970, all changes that were not consistent around the whole country caused the generation or creation of a new time zone. So for example, there are 2 time zones in Germany. Both of them start with B. One is Berlin, another one is not Bonn. Another one is Büsingen. If you imagine, look at the border between Germany and Switzerland, at the Rhine River, there is a tiny village that is like an enclave or exclave that is surrounded by Switzerland. And in 1979, one country started with daylight saving time, another country not. And this village, they forgot to start to do it together with Germany. They did it together with Switzerland. So they are actually identical. The historical information is identical to Europe Zurich, which is the Swiss time zone, but it's a German time zone. So Germany has 2 time zones. Ireland has only 1 time zone, it is Europe Dublin, and UK also has only Europe London. So now let's have a look at this information about time zones, about that is for Dublin. And you said in this standard off, there is the offset. There are some rules, format, and until. So every line, when there was some irregularity that changed, we had, or the maintainers, they had a new line. There are these rules that this GB IRI, or later there is this IRI, how to pronounce it, IRI? That is described somewhere else. IRI, okay, we are going to have a look at that. So this, if there is, in this code, everything you can see here, this is how the information is translated into the PYTZ or into dizzy data, and based on this information, dizzy data decides whether you are now in the daylight saving time or not. So in the 20s, I just I took a little bit this here. So you see this UK and Ireland used one rule because they switched the time together. But every year it was a little bit different, and you have always the Summertime Act from that year that decides whether they are going to switch in March, in April, or in September or October. Now the current rule for Ireland is this. So now you know that you switch the daylight saving time end of March and end of October, but it was not always like this until 1995. In Europe, we changed summertime, or the daylight saving time lasted until September. But here you see it is October. So it means, okay, I have in my head that in Central Europe it was until September, and here it was in October, but sometimes it was the Sunday from the 20th, so it was not always the last Sunday of October. So if now Ireland abolishes daylight saving time, these two lines that contain max will be replaced, and there will be new lines that, so this is for Dublin, and for London, it looks a little bit simpler because there were not so many exceptions in the 40s. And you see that London even defines the time zones of Jersey, Guernsey, and Isle of Man. There are some more informations, for example, which is interesting, why London has 1 minute and 15 seconds behind UTC, because behind Greenwich, and there is this information, a longer article about some old observatory in London. This is interesting. I have a 1 inch to 1 mile map of London. I would have to calculate how big the map actually is. And also this is a picture of, I think this is Bristol, end of 19th century, because they changed to the London time sooner or later, and they put another minute hand on the dial. Who knows what IST means? So, Nick, Ice, what do you think?
International Standard Time?
Irish Standard Time.
So it's
Irish
Irish summertime.
Yeah,
oh, it's Irish summertime. Yes, sorry.
It's summertime or standard time?
Standard, that is standard.
Yeah, I think it's standard as well, but you confused me now. I mean, I don't know.
So UTC, you know what UTC means?
Yeah.
UTC is actually a French-English abbreviation because it's a universal coordinated time, so UCT, or Temps Universel Coordonné, TUC. And French and English-speaking scientists, they wanted to find a compromise. They didn't want to use the French or the English abbreviation. They just put these 3 letters to some random order.
Yeah,
you see that
it's crazy stuff, is it not?
English and French. This is
so
this is in, sorry?
So no, go ahead, sorry.
Yeah. So this is IST, it is in English, and it means Irish time.
Nabankur is saying that IST is Indian Standard Time.
Yeah, of course, yes. It's also, that's the reason why you never should use these 3 letters abbreviations, because we have much more than 26 time zones around the world. So you don't, AST, BST, CST, and so on. We have many more countries and time zones around the world. So you cannot, IST is, of course, it can be India, it can be Ireland. So directly in this TZ data file, you will find such a comment from an anonymous contributor from 1996 that spoke this morning with the Secretary of the Department of Justice, telephone number, who confirmed to me that the correct name is Irish Summertime, abbreviated to IST. So it was summertime. But then, 20 years later, Paul Eggert is the maintainer of the TZ data. He wrote that these anonymous contributors, his goal was to determine the correct abbreviation for summertime in Dublin. And so he focused on the IST abbreviation and not on the Irish summertime. So IST was correct, but Irish summertime is error because since 1971, it is called Irish Standard Time. So actually you have standard time in summer and you have winter time, or what do you have? You have GMT, you have Greenwich Mean Time in winter. Is it do you in Ireland speak about summertime and wintertime, or how do you call this time in winter?
I think it's GMT, like, so wintertime. So it's summertime and then regular time.
Regular time, you say regular time. Okay,
yeah.
So there is standard time and regular time. Okay, standard time, regular time.
Eric is saying dark and rainy. That's how.
If you see that's the winter time, there are some countries or languages that use this term of winter time, summertime and winter time, but this winter time is wrong. There has never been a winter time in the world except for one country in one season. And that country was Czechoslovakia in 1946. And the parliament, they accepted a law that gave the government the possibility to declare winter time. It means we have standard time. Sometimes we have daylight saving time, like the summertime. And then we can have winter time, which is, I don't know, daylight wasting time, probably. And this is the law that the yellow text is, the government decree, the decree is from the 27th of November, 46, that on the 1st of December, 46, we are going to move even 1 hour back from the standard time. So there was the summertime or daylight saving time, there was standard time, and there started winter time or daylight wasting time on the 1st of December, 46, until the 23rd of February, 47. So this means it was only once and never again. But the law that allows the government to declare something like this in Czechoslovakia was valid. And 1993, Czechoslovakia split it into countries, Czech Republic and Slovakia. And both countries, they just took all the laws from before. And I have checked, the Czech government and the Slovak government are now allowed, still allowed, even after almost 80 years, to declare the winter time, if they wish. But wintertime or daylight saving time, it was not so easy in Europe. You see here, this is the graphic of the 70s and 80s, the year. And this, the 0 to 30, it is, I just took the countries of European Union, I think, or Central Europe, all these time zones. And I have added a 1 if these time zones started a daylight saving time, and then subtracted 1 when they stopped. So you see, at the beginning of 70s, there were a few countries in Europe that started with daylight saving time at different moments and stopped. And then it was more. In 1979, it was already half of them. But always you see this blue line that it always has tiny steps somewhere. And the tiny step somewhere means that 1 week later, 1 day later, there was another country in Europe that just started with daylight saving time. So you can imagine during these 15 years how it had to look like in Europe. So every country just in March or April, do they have daylight saving time or not? Because some countries started, some not. A year later, even more countries started with it, but they didn't do it at the same time. After 85, 86, it was fortunately it became coordinated. Let's have a look a little bit out of Europe, for example, at the border of Europe, for example, Istanbul. If you look at Istanbul at the times, this time zone information, you see there are regularities, but 2011, 14, 15, there are some extra entries. But usually Istanbul started with EU, you see these EU rules that are end of March until end of September or October. But sometimes they introduce their own exceptions. And the comment is, for example, Turkey will change into summertime on March 28 at 3 a.m. instead of March 27. This change is due to a nationwide exam on 27. So imagine that on the 10th of March, like 2 weeks before, they say, oh, we are not going to start the daylight saving time on Sunday, we are going to do it on Monday. Now you can imagine if you listen to the radio and they say, oh, okay, it's now 1 hour more or less, okay, your life will not change a lot. The train will leave earlier or later, okay. But now imagine there are some other systems that are really based on computers that have to work and that have to get this information at the right time. Airports, trains, international communication, meteorology and everything. So this was quite a big problem. But 2014, they didn't learn much. The DST for Turkey has been changed for this year because of the Turkish local election. So Turkey will move clocks forward 1 hour on March 31. The next comment, having landed on a flight from the States to Istanbul, I can tell you that nobody respected this time zone DST change delays. So absolute chaos. And the government just decided we are going to start the daylight saving time later or earlier. 2015, again, confused Turks are asking what's the time, EEST, Erdogan Engineered Standard Time. And then there is, in the code, there is a little, no change, but a lot of change in the text, because 2016, oh, we are going to stay in the daylight saving time, they didn't change it. So actually, the information came into this mailing list with a, yes, we are going to start or stop daylight saving time, or the plans are going to change, but the code had to change in both directions, and stay at the end, it didn't change at all. Caracas, this is Venezuela. The clocks advanced 30 minutes in 2 weeks, and then published in the official gazette. It means that the people who post into this mailing list, they just find some governmental newspaper in Spanish or in any other language, and they post the link to this newspaper article, and then we have to believe that it's like that. Of course, Spanish, more people understand. There are some other languages that a little bit less people understand. Port-au-Prince, this is Haiti. In summer, they have 13 hours of daylight. In winter, 11 hours of daylight. And still every year, since 10 years, they decide with 30% probability, are we going to introduce daylight saving time or not? And they decide it always like 2 weeks ahead. That's really late. If your government wants to change daylight saving time or anything with time zones, please do it ahead. So, in Pyongyang, Korea, South Korea in the 50s, they switched half an hour back. But this worked only within the country. Everything international was at the Korean time, 9 hours ahead. Pyongyang also, this is North Korea, they changed some stuff in 2015. And also, again, they, according to many news sources, they changed it only 1 week ahead. That's too late. And the last text here, it appears to be the front page story at the top in the rightmost column. You click on the link and you get a Korean newspaper with 10 columns, and there is some tiny text somewhere that tells me that the time zone is going to change. So have a look at this table or at this text. There's plenty of interesting information about the history. And never invent your own time zones. Don't hard-code any rules, like, is it the last Sunday of March? I'm going to do something. No, use the standard information from this data. Keep your time zones lips up to date, because they're going to change. You have seen that this year we had only one release, but sometimes there are a little bit few more releases up to 11. So every month you can have a release so closer to where you live, or use it, speak about the time zone that concerns you. Follow your government's intentions to modify your time zone and the mailing list, and if you can just avoid the time zones. Thank you.
Thank you. That was awesome. Yeah, we're getting claps on the chat as well.
Hilarious. Yeah, I've learned so much. I mean, it's crazy. Time, food for thought. Right. People in the chat room, if you feel like asking a question, I think now is the right time.
Perfect. So Mihai started already. So he said, "Well, just brilliant. Where does NTP come in?"
NTP, like you mean like NTP is the service that allows you to get the current time, and what your computer does with that? I don't understand exactly.
Let me see. He's permitted to talk now. I think he's gonna talk to us.
Let me give it a try. No, I'm just wondering. So looks like time zones are a huge problem, and keeping your time in sync is also a huge issue. I'm just wondering, if you're building a complex application that needs to know, local time zones and speak them out, where would using a service like Crony or NTP also factor into this decision? Is it affected by your choice of time zone, or is there something that's typically applied? The time zone is applied on the time that is synchronized on NTP.
Linux computers, they run on central clock is always UTC. You say I want the current time, like your computer, if it is set to to Europe Dublin time, it will calculate the local time for you. But NTP doesn't need to know what time zone you are living in. No, not at all, because it tells you actually now it's UTC, and you know how to. It is your problem to calculate the local time based on. I wouldn't take care of NTP at all. NTP just gives me the current time in UTC.
Another question here. So most of these time shift, you know, like maybe between Moscow and Paris is 3 hours because of the longitude, you know. So obviously the sun has set in Moscow, and still some remains of daylight in Paris. So far, so good. So the question is, what time is it on the North Pole? Whatever I want?
Yeah.
I loved it. The only place where west is in front of me, just like north, right?
Yeah, if there is North Pole, you just walk. You walk to the north and you walk to the south. And you turn around, walk to the north and you walk to the south. It works like that. Have you tried? Did you try it?
Yeah, I wish. So I can walk an entire day in a matter of minutes, right? Just walking around that single broomstick in the snow, and happy days, right? All right. I don't know the title. It reminds Umberto Eco wrote a book which is called The Island of the Day Before, where they believe like if you swim in the water, you know, just at the edge of this 180 degrees, you can travel back in time. That's probably something worth reading. Any more questions from the general attendance here?
So from Zoom, not yet. The Lullaby Taki in Twitch is saying superb information, thank you. And then he's saying, well, fortunately in India, they don't have DST, but no question.
Well,
it would be
excellent.
Nice to live without DST. Because here in Central Europe, around 50 degrees of latitude, we have 16 hours of daylight and 8 hours of daylight, like in summer and in winter. So we have in the morning, it moves by 4 hours, and evening by 4 hours. So if you have daylight saving time, it's just 1 hour. That doesn't bring so much. So I would be happy to be without daylight saving time. And actually here to have the border between Central European time and West European time. So French should get their West European time. If you would like to get the Iceland time in Ireland.
So we have another question there. Is the Linux and Windows or Mac OS would use the same IANA.org tables to switch their DST local times?
That's a good question. I think MS-DOS uses some, they have a little bit different information, because sometimes you get the choice of time zone, and there is like Amsterdam, Brussels, Paris, and so on together, and then there is Berlin and Rome together. So probably but for the current information, they have to be based on the IANA, because IANA is the only source of information that collects really everything. You don't want to use anything else. And it will be also interesting if you store some time somewhere to also write it in which version of IANA are you using. But this is, of course, if we are going to let's start a meetup next year in June at 7 p.m. Of Irish time, and there will be some change. Of course, it's not we are all going to be 1 hour ahead. For future time zones, for future timestamps, you have to save it. You shouldn't convert to UTC. Actually, you should use some textual information or even visit land.
Okay, perfect. So we have no more questions here. We have no more questions in Zoom. Thank you so much. That was incredible.
Thank you very much.
How is your beer?
It's almost warm. It's quite warm here.